Vast Haven-1, a $1 billion commercial space station set to revolutionize low Earth orbit operations.
Overview.
Vast Space, a pioneering company in the field of space habitation technologies, is on the brink of launching Haven-1, the world's first commercial space station. Slated for a 2025 launch, this $1 billion initiative seeks to transform low Earth orbit LEO operations, creating a versatile platform for scientific research, commercial opportunities, and private astronaut experiences. With a human-centric design and strategic partnerships, Haven-1 aims to set a new standard for living and working in space.
Key features and specifications.
Haven-1 is designed with impressive specifications that highlight its suitability for various missions. The station features a diameter of 4.4 meters, a height of 10.1 meters, and a habitable volume of 45 cubic meters, allowing it to accommodate up to 4 crew members for missions lasting 2 weeks.
A striking 1.1-meter domed window provides breathtaking views of Earth. While the interior includes personal crew quarters, a communal area with a deployable table, and a dedicated research lab. Connectivity is a priority. Haven-1 will utilize SpaceX's Starlink for high-speed, low-latency internet, enabling crew members to conduct outreach and experiments with ease. This connectivity makes it possible for astronauts to stay in touch with loved ones and share their experiences in real time. Mission structure and use cases. Haven-1 will support a diverse range of mission types, including 1. Government and industry missions, collaboration with space agencies and private companies to conduct scientific research and technological development.
2. Private astronaut experiences, opportunities for individuals to experience space travel, participate in research, and contribute to scientific advancements.
3. Payload missions, conducting experiments and in-space manufacturing, leveraging the unique microgravity environment. Each mission can be booked per seat or as a complete crew. Enhancing accessibility for various stakeholders in the space industry. Design and comfort innovations.
The interior of Haven-1 is crafted with astronaut well-being in mind, drawing on insights from veteran astronauts and renowned designers.
The layout features private quarters that allow for rest, entertainment, and online communication.
A patented sleep system designed to improve sleep quality and microgravity will be a key highlight, addressing the common discomforts associated with sleeping in space. The communal area serves as a multifunctional hub for collaboration, exercise, and relaxation. It boasts a significant volume of 24 cubic meters, featuring the expansive observation window and a deployable table for communal activities.
Strategic partnerships. Haven-1's launch will be facilitated by SpaceX, which will provide the Falcon 9 launch vehicle and Dragon spacecraft. A critical aspect of this partnership is the incorporation of Starlink's laser connectivity, ensuring that Haven-1 will have unparalleled internet access in orbit.
This collaboration not only enhances operational capabilities but also paves the way for future endeavors, including bids for NASA's Commercial LEO Destinations (CLD) program.
Timeline of key events.
1. 2021, VAST is founded, focusing on space habitation technologies.
2. 2023, announcement of the partnership with SpaceX for Haven-1's launch and connectivity.
3. 2025, scheduled launch of Haven-1 and subsequent human spaceflight missions. For 2025 and beyond, planned development of additional space stations, including potential artificial gravity stations by the 2030s.
Conclusion. Haven-1 represents a significant leap forward in commercial space exploration.
By merging innovative design with practical functionality, VAST is redefining the astronaut experience and setting a new standard for future commercial space stations. With its commitment to human-centric design and strategic partnerships, Haven-1 is poised to revolutionize life and work in space, paving the way for a future where humanity thrives beyond Earth. The development of Vast Haven-1 as the world's first commercial space station introduces several counterintuitive elements that challenge traditional perceptions about space operations and human habitation in low Earth orbit. 1. Commercialization versus government dominance. Historically, space exploration has been dominated by government agencies like NASA and Roscosmos. The emergence of Haven-1 as a commercial space station suggests a shift towards privatization in an area long considered the domain of state-funded projects. This raises questions about the sustainability and efficiency of commercial ventures in space compared to government initiatives which have typically prioritized scientific research and international collaboration. 2. Focus on human-centric design. The emphasis on creating a human-centric environment within Haven-1 is counterintuitive in the context of traditional space habitats, which have often prioritized functionality and safety over comfort. By integrating features such as personalized sleeping quarters and communal areas designed for social interaction, VAST is redefining what it means to live and work in space. This approach suggests that astronaut well-being can enhance productivity and innovation, challenging the notion that space environments must be utilitarian and austere. 3. Artificial gravity aspirations. The long-term goal of developing artificial gravity in future stations contrasts with the current experiences of astronauts who must adapt to microgravity. While most space missions have accepted microgravity as a given, VAST's aim to create environments with artificial gravity reflects a fundamental rethink of how humans can sustainably live and work in space without the adverse health effects associated with prolonged exposure to microgravity. 4. Connectivity and digital integration. The integration of SpaceX's Starlink for high-speed internet access on Haven-1 is a significant departure from previous space missions where connectivity was minimal and often unreliable. This counterintuitive focus on digital connectivity suggests that a robust internet presence is essential not just for scientific collaboration but also for psychological well-being among astronauts, enabling them to maintain connections with loved ones and the outside world. 5. Accessibility for private astronauts. The model of allowing private individuals to participate in missions to Haven-1 is an unprecedented move that suggests a democratization of space travel. This contrasts sharply with the highly selective nature of astronaut programs historically governed by strict training and selection criteria. The idea that private citizens can now access space for research or leisure purposes challenges traditional views about who can be an astronaut and what space travel entails. 6. Sustainability and long-term habitation. The vision for Haven-1 includes not only short missions but also a framework for long-term habitation. This is at odds with the conventional wisdom that space missions, particularly in microgravity, must be short-lived due to physical and psychological tolls on astronauts. VAST's focus on creating a sustainable environment for long-term research and habitation indicates a paradigm shift in how we approach living in space, emphasizing adaptation and resilience. 7. A collaboration with SpaceX. The strategic partnership with SpaceX for launch and connectivity is notable as it illustrates a trend where commercial entities leverage each other's strengths to achieve ambitious goals. This collaboration counters the expectation that space endeavors should primarily rely on government contracts and funding, instead showcasing a model where private companies can work together to innovate and expand human reach in space. 8. Microgravity research and development. The establishment of a dedicated lab within Haven-1 for microgravity research and in-space manufacturing challenges the notion that significant research should only occur in large, government-funded facilities like the ISS. By making microgravity environments more accessible to various stakeholders including private researchers and companies, Haven-1 is set to catalyze a new era of innovation that could lead to breakthroughs in various fields. These counterintuitive aspects of VAST Haven-1 indicate a significant evolution in the landscape of space exploration and habitation, suggesting that the future of human activity in space may be more collaborative, accessible, and focused on human experience than previously imagined. The VAST Haven-1 space station project is a major milestone in the evolution of commercial space exploration, and while many aspects of the initiative have been highlighted, several key elements may be overlooked by the casual observer. Here are some critical aspects worth noting. 1. Human-centric design approach. The emphasis on human-centric design in Haven-1 led by experienced astronauts and top designers.
represents a significant shift in space habitat development.
The involvement of industry veterans like Andrew Feustel and Peter Russell Clark highlights a commitment to astronaut well-being which could improve both the quality of life in space and the efficiency of scientific work. Significance: the focus on comfort such as private sleeping quarters and a communal area designed for collaboration could reduce stress and enhance the overall experience for astronauts. This approach may lead to more effective research outcomes as crew members are better rested and more engaged. Furthermore, it sets a precedent for future space habitats by prioritizing the human experience, potentially influencing design across the industry. 2. Advanced connectivity with SpaceX Starlink. Haven-1's integration with SpaceX's Starlink for high-speed internet access is a significant technological advancement. This connectivity facilitates real-time communication with Earth, access to data, and the ability to perform remote monitoring of experiments. Significance: the ability to maintain continuous high-quality connectivity in space is crucial for both scientific research and crew morale. This allows astronauts to conduct experiments that require constant data input and monitoring, thus opening up new avenues for research that were previously impractical in a zero-latency environment. It also allows for greater interaction with the public and educational outreach which could inspire future generations. 3. Versatile mission structures. Haven-1's capability to support a wide range of missions spanning government, industry, and private astronaut experiences demonstrates a versatile business model that could attract diverse stakeholders. Significance: this versatility is crucial for the sustainability of commercial operations in space. By catering to various mission types, VAST can optimize utilization of the station and generate revenue from multiple streams. The potential for in-space manufacturing and scientific research can also drive innovation and attract investment in the broader space economy. 4. Emphasis on artificial gravity. VAST's long-term vision includes the development of an artificial gravity station which could mitigate the adverse effects of microgravity on human health. Significance: artificial gravity is a game-changer for long-duration space missions. The health implications for astronauts are profound, as prolonged exposure to microgravity can lead to muscle atrophy and bone density loss. Developing a space station that can simulate Earth-like gravity could enable longer missions, making deep space exploration more feasible and safe for human crews. 5. The role of aesthetic and functional design. The exterior and interior aesthetics of Haven-1, including the use of natural materials and warm designs, contribute to the psychological comfort of astronauts. Significance: aesthetics in space design have often been overlooked in favor of functionality. However, creating a visually appealing environment can significantly impact the mental health and well-being of astronauts. By incorporating elements that mimic Earth's environments, VAST may help reduce feelings of isolation and improve crew cohesion during missions. 6. Strategic partnerships and future prospects. The collaboration with SpaceX for both launch and connectivity is a cornerstone of the Haven-1 project, ensuring reliability and technological advancement. Significance: such partnerships exemplify a growing trend in the commercial space sector where collaboration can enhance capabilities and reduce costs. The strategic positioning of VAST within this ecosystem not only boosts its credibility but also increases its chances of winning future contracts such as NASA's Commercial LEO Destinations program. 7. Modular and adaptable space design. The design of Haven-1 allows for modular components, such as the deployable communal table and configurable lab spaces. Significance: this adaptability is crucial for optimizing space usage and accommodating varying mission needs. Such designs can lead to efficient space management, allowing for the reconfiguration of areas based on mission demands or crew preferences. It signifies a shift towards more dynamic habitats in space. 8. Educational and outreach potential. Haven-1's design and capabilities could enhance educational outreach and inspire public interest in space exploration. Significance: By enabling astronauts to communicate and share their experiences with the public in real time, Haven-1 could serve as a platform for STEM education and public engagement. This is vital for fostering a culture of interest in space, which can lead to increased support in funding for future missions. Conclusion: the vast Haven-1 space station is not just a commercial venture, it is a transformative step towards redefining human presence in space. By emphasizing human-centric design, advanced connectivity, versatility, and future-oriented innovations, VAST is setting a new standard for what space habitats can achieve. The significance of these elements extends beyond technical specifications, impacting astronaut well-being, scientific research, and the overall narrative of humanity's venture into space. As Haven-1 prepares for its launch, the implications of this project could resonate throughout the space industry for years to come. The launch of VAST's Haven-1, slated for 2025, marks a significant milestone in the evolution of commercial space exploration and habitation. Here are 4 critical points for in-depth analysis and discussion. 1. Human-centric design and well-being in space. Haven-1 prioritizes the well-being of astronauts through innovative design elements that address the unique challenges of living in microgravity. The collaboration with experienced astronauts and renowned designers has led to a focus on creating spaces that enhance comfort and functionality. Features such as private crew quarters, a communal area, and a dedicated research lab are designed to improve the quality of life for astronauts. Notably, the patented sleep system aims to mitigate common sleep issues faced by astronauts in space, representing a significant step toward more sustainable long-term missions. Analyzing the impact of such design innovations on astronaut performance and mental health will be crucial in understanding their effectiveness in extended missions. 2. Versatility and accessibility of mission types. Haven-1's operational model is remarkably versatile, catering to a broad spectrum of stakeholders, including governments, industries, and private astronauts. By allowing missions to be booked per seat or as complete crews, Haven-1 enhances accessibility to space activities. The station can serve as an innovation lab for scientific research, a platform for in-space manufacturing, and a venue for private astronaut experiences. This operational flexibility not only broadens the potential user base but also fosters collaboration across various sectors, thereby driving innovation in microgravity. Analyzing the implications of this model on the commercial space industry and potential partnerships could provide insight into the future of space exploration. 3. Strategic partnerships and technological integration. The partnership with SpaceX to launch Haven-1 and provide Starlink connectivity is a significant strategic move, ensuring high-speed, low-latency internet access for astronauts. This connectivity will facilitate real-time communication, remote monitoring of experiments, and improved outreach capabilities. The integration of cutting-edge technology will be pivotal in enhancing research and operational efficiency aboard the station. Discussing the role of such partnerships in advancing commercial space initiatives as well as the broader implications for international collaboration in space exploration will be essential for understanding the future landscape of space habitation. 4. Future aspirations and the vision for artificial gravity. VAST's long-term vision includes developing a fully operational artificial gravity station by the 2030s and competing for NASA's commercial LEO destinations program. This ambition highlights a critical shift in the approach to human spaceflight, focusing on long-term habitation and the physiological effects of microgravity. The potential for artificial gravity environments could revolutionize how humans live and work in space, mitigating some of the adverse effects of prolonged exposure to a zero-gravity environment. A thorough examination of the technological and scientific challenges involved in creating artificial gravity alongside the potential benefits for human health and performance in space will be vital for understanding the feasibility of this ambitious goal. Conclusion. The VAST Haven-1 project embodies a transformative approach to commercial space stations, combining innovative design with operational versatility and strategic partnerships. By focusing on human well-being, accessibility, technological integration, and future aspirations, Haven-1 sets a new standard for the future of space habitation and exploration. Analyzing these key points will offer valuable insights into the trajectory of commercial space initiatives and their implications for humanity's future in space. 1. Axiom Space's Axiom Station. Axiom Space is developing the Axiom Station, which aims to be the world's first commercial space station. Scheduled to launch in the late 2020s, Axiom Station will initially be attached to the International Space Station (ISS) and will eventually operate independently. It is designed to support scientific research, technology development, and commercial activities in low Earth orbit. The station will provide private astronauts and researchers with opportunities to conduct experiments, engage in manufacturing, and experience living in space. 2. Tiangong Space Station. The Tiangong Space Station, developed by China, is another significant project in the realm of commercial and government space operations. Launched in segments starting in 2021, Tiangong aims to support a variety of scientific research, international collaboration, and crewed missions. The station is designed to accommodate astronauts for extended stays, allowing for diverse scientific experiments and technology demonstrations in low Earth orbit. Tiangong represents China's commitment to becoming a leader in space exploration and habitation. 3. International Space Station (ISS). The ISS has been a cornerstone of international cooperation in space since its first module was launched in 1998. It serves as a research laboratory where astronauts from various countries conduct experiments across multiple disciplines, including biology, physics, and earth science. The ISS has also played a pivotal role in advancing technologies for future space exploration, including commercial opportunities in low Earth orbit. As the ISS approaches the end of its operational life, projects like VAST Haven-1 and Axiom Station aim to fill the gap in human spaceflight capabilities. Future outlook: VAST Haven-1 and the evolution of commercial space stations. As we approach the launch of VAST's Haven-1 in 2025, the future of commercial space stations and their potential to revolutionize low Earth orbit LEO operations becomes increasingly tangible. With a projected investment of $1 billion, Haven-1 is poised to redefine scientific research, commercial opportunities, and the overall experience of astronauts in space. This innovative venture is just the beginning of a broader trend toward the commercialization of space, which can lead to significant advancements in various sectors. 1. Expansion of commercial space operations. Haven-1 is expected to pave the way for an expanded commercial presence in space. As the world's first commercial space station, it serves as a prototype for future stations that will cater to both private and governmental missions. Following Haven-1, we anticipate subsequent versions such as Haven-2 that will further enhance capabilities and accommodate larger crews or longer missions. The success of Haven-1 could attract additional investment from both private industry and government, leading to a proliferation of commercial stations operating in LEO. 2. Advancements in space research and manufacturing. One of the key features of Haven-1 is its focus on scientific research and in-space manufacturing. The station will allow researchers and private companies to conduct experiments in microgravity, which can yield novel materials and pharmaceuticals that are difficult or impossible to produce on Earth. The ability to perform in-space manufacturing could lead to the development of new industries, including space-based production of goods and advanced materials that could be sent back to Earth or used in future space missions. 3. Enhanced connectivity and communication. With the integration of SpaceX's Starlink technology, Haven-1 will provide unprecedented high-speed, low-latency internet connectivity for its crew. This capability will not only enhance the quality of life for astronauts but also allow for real-time collaboration with researchers and institutions on Earth. The implications of this connectivity extend beyond just communication. It opens the door for telemedicine, remote monitoring of experiments, and live streaming events that can engage the public and increase interest in space exploration. 4. Shift toward artificial gravity. Vast's ambition to develop artificial gravity stations by the 2030s could fundamentally change human habitation in space. Current space stations like the International Space Station ISS operate in microgravity, which presents various health challenges for long-duration missions. The realization of artificial gravity could mitigate these issues, allowing astronauts to live and work in an environment more akin to Earth. This innovation would not only enhance astronaut well-being but also enable longer missions deeper into space, potentially supporting future colonization efforts on Mars or the Moon. 5. Commercial space travel for private astronauts. Haven-1 opens the door for private astronaut experiences, which are likely to become a popular offering in the commercial space sector. As ticket prices decrease and accessibility increases, more individuals will have the opportunity to experience space travel. This democratization of space could foster a new era of explorers and enthusiasts who contribute to the growth of the space industry. Additionally, this trend could lead to the development of space tourism as a viable market, stimulating economic growth and inspiring new generations to pursue careers in STEM fields. 6. Collaboration with government entities. Haven-1's versatility in accommodating both private and government missions positions it as an essential asset for national space agencies such as NASA, as agencies look to transition from reliance on the ISS. Commercial stations like Haven-1 will play a crucial role in carrying out scientific experiments and testing technologies needed for future exploration missions. The collaborations between commercial entities and governmental agencies will enhance the overall capabilities of space exploration and research. 7. Global space policy and regulation. As commercial operations in space expand, the need for comprehensive global space policy and regulation will become increasingly critical. The establishment of clear guidelines regarding space traffic management, resource utilization, and environmental considerations will be necessary to ensure sustainable practices in space exploration. Vast's proactive approach in collaborating with regulatory bodies will set a precedent for future commercial endeavors, fostering an environment that encourages innovation while protecting space as a shared resource. 8. Cultural and societal impact. The launch of Haven-1 and the subsequent growth of commercial space stations will likely have profound cultural and societal implications. As space travel becomes more accessible, public interest in space exploration will rise, potentially leading to a cultural shift that prioritizes investment in science and technology. Educational programs aimed at inspiring youth to pursue careers in space-related fields may flourish, contributing to a more informed and engaged populace. Conclusion. The launch of Vast's Haven-1 represents a significant milestone in the evolution of commercial space exploration. As we look to the future, the potential for growth in various sectors, including research, manufacturing, tourism, and global collaboration, becomes increasingly evident. By establishing a robust commercial presence in low Earth orbit, Vast is not only redefining how humans live and work in space but also laying the groundwork for further advancements that promise to benefit life on Earth and beyond. The next decade will likely see a surge in innovation and opportunity, transforming our relationship with space in ways we are just beginning to imagine.